Hello, this is Naga Sai. As we have studied the concept of CNN and has this basic understanding, so now we want to apply it and do some interesting project. So why I have chosen this topic? I found this topic handwritten digits recognition very interesting because even we have only 10 possible cases, we are mentioning that handwritten. So now we are not restricting to particular style of writing digits. We have different styles that we are checking. So even it has 10 possible cases for different styles, we need to check for large data sets. So basically, we are doing digit recognition on real life images containing handwritten digits using CNN. Handwriting recognition systems receives the input from the touchscreen, electronic pen, scanner, images, and paper documents. So have you ever wondered how this interface is working? Actually, after taking this input, it is processed and provides the output as a digital document suitable for subsequent access and manipulation. This problem is resolved by full functional model that helps a user to solve the problem of converting handwritten format to digital format. In search of this, for executing our project, we have used these references. Handwritten document recognition is a critical task in the field of pattern recognition. It has an array of application wherein recognition of words, alphabets, digits, and other characters are the mandate. So the review article mainly focuses review on CNN-based handwritten document recognition system. Particularly in this project, we are doing it for handwritten digits. So challenges. So challenges here are considerable variety in the handwriting from person to person. And the concepts used are basic image processing techniques and CNN. So we will focus on the flow of the model, like how you are going to model it. So this is the image data set on handwritten digits for training set. And now we would focus on actual network of CNN model. So here it is a standard image dataset for handwritten digits, and this is the actual CNN model. So the first layer takes in an input image of shape here is 28 cross 28 cross 1, where 1 signifies grayscale image. In between the convolution 2D layers and the dense layer, there is a flatten layer. Flatten serves as a connection between convolution and dense layer. Dense is a layer type which is being used for the output layer. Dense is a standard layer type that is used in many cases for neural networks. So here we will be using 10 nodes in our output layer, one for each possible outcome from 0 to 9. The activation function is softmax. Softmax makes the output sum up TP1 so that output contains a series of probabilities. So the model will predict the one with highest probability. So steps that are involved in this model. First one, pre-processing. At this stage, because all images in the databases are clean and without noise, so no noise reduction technique is required here. But in real-time system, we need to remove noise from the images. And the second one is segmentation. After the processing step, an image of sequence of digit is decomposed into sub-images of individual digit. The third one is feature extraction. After the segmentation step, segmented image is given as input to the feature extraction module. Training. After the feature extraction step, CNN is trained with the training images. And finally, classification and recognition. After the training step, the classification and recognition stage is a decision-making part of recognition system, and it uses the features extracted in the previous stage. So what are we going to show in our execution? So we would showcase the CNN model outcomes for single digit in testing stage after properly training the network. And then we take the real image which is having a line of numbers, and we would try to segment it and showcase each of the digits separately. So further approach can be done on extending this project for detecting handwritten characters also, so that we have applications in real-time problems. So when we extend our project from our handwritten number recognition to handwritten letter recognition and further handwritten character recognition, then we can merge it and we can apply it for document analysis, mailing address interpretation, bank check processing, signature verification. So sir, here I just completed a small brief of our project. It's not a complete explanation of how we are going to model and execute. So such things like modeling our neural network for recognizing handwritten digits and explaining each of those steps can be done in further. So now let's start with our code. So we are fetching a MNIST dataset of 70,000 handwritten digits and train a CNN on it for recognizing digits. So these are our libraries and modules that we are using. So we have these main modules and for neural network modules. So for implementation of CNN and all the pre-processing related to it, we will be using Keras. So firstly, let's load our dataset. Here we are initializing the dataset and segregating into the test and train set. So we get the values and labels of both train and test set. So now we want to display and check the train images as we have associated labels. So randomly, I'm displaying and checking for the labels. So here we can see that the output image is 5 and the output label associated with it is also 5. Similarly for 0. And also we can notice that the 4 that is written over here is different from the 4 that is written over here. But the output label should be 4. So keeping this in mind, we need to design our CNN. So now let's begin the data processing. This is the most important part of training a model. We have to make sure that our model looks at the data set the way it wants to, so that the model doesn't get trained in a messed up manner. So here we are checking the initial shapes. So we get 60,000 train set and 10,000 test set. And the shape of each image is 28 cross 28. So train set has 60,000 images and test set has 10,000 images, which is a very right fit considering the training. So we need to reshape our data sets to the shape that our model expects when we train the model. And let's check it out the shapes of updated train and test set. So now before building the model, actual CNN model, for the whole operation, the model expects each of the label to be in the form of an array of 10 elements in which only one of the element equal to 1, the element or node with highest probability, and rest equal to 0. So for example, if the image is of number 5, then the label, instead of being equal to 5, it will have a value 1 in column 6 and 0 in rest of the columns. So for that, we are using command to categorical for labels. So now let's look at the actual model. So the model type that we will be using here is sequential. Sequential is the easiest way to build a model in Keras. It allows to build the model layer by layer. The first two layers are convolution 2D layers. These are the convolution layers that will deal with our input images, which are seen as 2D matrices. And the main task in designing CNN is estimating the nodes of layers. So we check for various cases. And particularly here, we are using 32 nodes in the first layer and 64 nodes in the second layer. And these numbers can be adjusted accordingly depending on the size of the dataset. In this case, 32 and 64 seem to be working fine. And we will have 10 nodes in our output layer, one for each possible outcome. And the kernel size that we are using here is 3, which is the size of the filter matrix for our convolution. The activation is the activation function for the layer. The activation function here being used for the first two layers is the ReLU, or rectified linear activation. So this function outputs 0 if the input is a negative number and the output is the same input if the input is a positive number. And finally, add function is used for adding successive layers. And then comes the optimizer. Here the optimizer that is being used is Adam optimizer, which actually controls the learning rate. And the loss function that is used here is categorical cross entropy. It is a most common choice for classification. A lower score corresponds to the better performance. And the metrics. Metrics to see the accuracy score on the validation set while training the model. So now training the model. Model will train on train data, train valve and train label and validates on the test data, test valve and test label. Here we are checking for three epochs. Even you can increase the number of epochs for better accuracy. But here with three epochs, a remarkable accuracy gets achieved. An accuracy that we are getting here is nearly 97.48%, which is a better accuracy. So now predicting and testing on a current data set. So we are checking for different test samples and getting results from CNN model and comparing it with the actual image. So here we can see the actual image is 3 and the final output from the CNN model is also 3. And also we can see here as it is a 3, we are getting 1 at column 4. And also for other images, we got proper results. As we can see here, 6, and the final output is 6 and getting 1 at column 7. And 1 image and output from CNN is also 1 and getting 1 at column 1. Even for 5, the output is from CNN is 5 and getting 1 at column 6. So now we move on to the main part of our project to check it on a real images. Here we have a test image having a line of numbers. So as we already designed a model for particular digit to be identified using CNN. So now here the challenge is we need to divide the digits, i.e. we need to segment an image and should give each of the digit to a model that we designed earlier and get the results. So here we are doing pre-processing the real life image. So first we convert image to grayscale. And later by putting the thresholds on this grayscale image in such a way that only the digits in the image is white and the rest is black. Now using this image and command find contours in the image, here contours will provide us the individual digits in the image. Now we have the digits, but we have to modify it further in such a way that it becomes a lot more similar to the images present in the training data set. So here we are creating a rectangle around the digit in the original image for displaying the digits fetched via contours. And then we are cropping out the digit from the image corresponding to the current contours in the for loop. Now we are modifying our image. So we are resizing it to 18 cross 18. Then we will add a padding of zeros, black color of 5 pixels in each direction. So the final padded image will be of size 28 cross 28. And then we add this pre-processor digit to the list of pre-processor digits. So the image would be like this, where each digit can be separated properly. Now we are inputting these pre-processor digits and giving it to our model. Thereby we can get the digits that are there in the test image and also corresponding hard maxed form, which will be our final output. So we can see that the digits that are there in our image are 0, 2, 5, 1, 2, 8, 9, 5, then that's it. So here we can notice that the order of digits might not be the same, but the digits are properly detected. as in the test image. So this will be our final code conclusion.